Alright, so this is your tutorial for the percent yield practice. This is for the first 5 questions that you're doing. But what I need you to understand is that you're going to go ahead and find this on Teams. So make sure that you're looking at the folder that says MP3 week 7 through 9. And then it says the percent yield practice 1 through 5. Okay, so for most of you, I would have already done this first example. And it's super guided, so everything there is lined up for you. But what I'll do is I'll go ahead and help you out with number 1 again if you didn't quite understand it. We can even go over this is guided too. We'll go over number 1, number 2, number 3, I'm sorry, and number 4. And that'll get you started where in reality, if you're watching this video, all you have to do is number 2 and 5. Make sure that you're showing all your work. It's on a separate sheet of paper and that you're turning it in on time. Alright, so on the first problem, this is a setup that you have, which I expect you to absolutely write the entire thing. This is a mass-to-mass problem, so if you look back at your foldable, keep in mind that you have this, which is your setup, and it says 1 mole of A over molar mass grams of A. So we've got to get the molar mass of C3H8. If you recall, okay, here's your molar mass of C3H8. All right, and you've got 3 carbons, 8 hydrogens, and then you're going to multiply it by the masses on the periodic table. So if you look at your periodic tables, you're going to find that carbon is 12.01 rounded to the nearest hundredth, and hydrogen is 1.01. Remember, multiply the 3 by 12.01, that gives you 36.03. 8 times 1.01, that gives you 8.08. So you add them. Let me go ahead and indicate that. And it's 44.11 grams per mole. And again, this is a molar mass of C3H8. So I'm going to go ahead and put that number right here. Okay, moving along, you get to the ratio step, which is right here. You have number of moles of B over number of moles of A. So A is going to be the initial or the given substance, and B is going to be the substance that you're looking for. So in the blanks, you're going to put the coefficients for those substances. So we're going to go back to our formula. We look up H2O, okay? So if we look up H2O, the coefficient for that one is 4. So therefore, we're going to put 4 here. And the coefficient for C3H8, again, looking at this, is 1. So we're going to place a 1 here. All right, going along with what we're doing. So we have 1 mole of H2O as is indicated in our foldable, and then we're going to do the molar mass of H2O. So just like we did the molar mass for the previous one. Guys. Okay, we're going to do the molar mass for water, which is 2 hydrogens at 1.01. So multiplied is 2.02. 1 oxygen times 16. Add the 2 up, and you get 18.02. So we're going to put 18.02 right here. Okay, once you have that, you're going to multiply all this across. You're going to multiply all the bottom numbers across. And then you divide the top answer by the bottom answer to get your final answer. That's going to represent your theoretical yield. Okay, once you do the math for it, you're going to find out that it ends up being 8.17 grams of H2O. Again, this represents your theoretical yield. And again, we're trying to find, remember, your percent yield. So if we look at how we're calculating it, or what the equation is, the formula, it's going to be the actual yield over theoretical. On an exam, if you ever forget this, just remember that actual has a letter A. It's the first letter in the alphabet, and it comes before T for theoretical. The other thing you need to keep in mind is 9 times out of 10, you'll see that the smallest number is on the top and the largest number is on the bottom. And you don't want to forget to multiply by 100. So we have our 8.17, which I said is our theoretical. That's going to go on the bottom. And keep in mind also that here they gave you your actual, and it tells you it produces. Any number that is tied in with the word produce is always going to be your actual yield. So this is our actual. And over here, what we discovered or we calculated, that's our theoretical. All right, so now the final answer here is 75.28%. Remember, actual was 6.15 grams. That was already in the question. And theoretical is what you calculate, which is the 8.17. And just again to remember that you more than likely 9 times out of 10, the smallest number is on the top, the biggest number is on the bottom. Again, 9 times out of 10, not 100% all the time, but most of the time. Times 100, so it ends up being 75.28. And that is our answer for number 1. Okay, so for number 3, notice that there's really not as much help as the other ones. And you're going to have to determine what's your given, what's your actual. So remember that what I said earlier, if it has the word produced or produces tied into that number, that's going to be your actual. And the other number is the given. So if you look at 3 and 4, here, this number, the 107, is attached to produce, so it's going to be my actual. The other number is my given. If I look at number 5, you look for the one that has the word produce near it. So here, to produce 220 grams of FES. So that's going to be your actual. Okay, sorry about that glitch. So now what you're going to look at is the fact that whatever's tied into the word produce, like this one, 220, that's going to be your actual, and the other amount is going to be your given. Okay, so we start just like before with a mass-to-mass problem. Okay, as we do the third problem, okay, we start with what we decided was going to be our given. So in this case, the 14 grams of H2O. And keep in mind that the actual, we don't use it until we use this formula here. Okay, so 14 grams of H2O. Again, you can refer back to your foldable, or you can go off of what you have as information. So if we start with grams, our first step is going to be with molar mass. So this has to go and be repeated diagonally. So this is grams of H2O. Anytime you have grams, the step either above it or below it is always going to be 1 mole of whatever this compound is. Okay, so in this case, H2O. So I'm going to get the molar mass of H2O, which we already know from the previous problem, and it's 18.02 grams per mole. That goes here. Okay, when we do a molar mass problem, automatically, or a molar mass, step, automatically the next step is going to be the molar ratios. And for the molar ratios, remember, it's moles on top and moles on the bottom. This substance gets repeated here, so it's moles of H2O, and this substance is going to be the one we're looking for. So we're looking for grams of O2. So that means that the substance is O2. Don't forget that the numbers that go in the mole ratios are going to be the coefficients in the equations. So for this one, okay, it's going to be that we're using H2O and O2. So O2 has a coefficient of 1 and H2O has a coefficient of 2. So 1 and 2. Okay, so now the next step is a molar mass step. Again, remember, it involves grams. So if you notice, this says moles of O2. We're not going to put the grams diagonal like we did here when it was a molar mass step. We're going to put the 1 mole this time on the bottom because it'll cancel diagonally with what was before. And we're going to put the grams of O2 above it. Okay, so we're going to get the molar mass of O2. And again, if you forgot, you have 2 oxygens. So 2 times the mass on the periodic table, which is 16, is 32. So that's going to be our molar mass for oxygen. Okay, once you do that, you multiply all the numbers across from the top, all the numbers across from the bottom, and divide the top by the bottom answer to get your final answer there. All right, so once I calculate it, it's going to end up being 12.43. And don't forget, whatever you come up with as an answer, that always represents your theoretical. So on the question, we labeled this one as actual. Again, why? Because it had the word produce with it. So our actual is going to be our 12.3. And again, it's from the question, 12.3. That's our actual, divided by our theoretical, our 12.43, which is what we got. multiplied by 100. Okay, so divide the 2 multiplied by 100, you get an answer of 98.95%. So that's our final answer there. Okay, and then I'll do the fourth one also as an example, and you're going to see that it's pretty much the same way. Okay, looking at number 4, we decided earlier that our actual is 107.107 grams of oxygen, so we're not going to use this yet. So we go into looking at the given, which is the 300 grams of KClO3. So our given always starts off our mass to mass problem. So 300 grams of KClO3. And just like we did above, same steps, molar mass, molar ratios, molar mass, that's exactly what we're going to do. So this has to be grams of this one, just like we did here. This was grams of H2O, grams of H2O. If this is grams of KClO3, this will be grams of KClO3. And remember what's always paired up with grams? 1 mole of the same substance. So now we have to find the molar mass of KClO3. Okay, so I calculate the molar mass. It'll look like this: 1K, 1Cl, 3 oxygens, multiplied by their masses on the periodic table, add them up. My molar mass is 122.55 grams per mole. So 122.55 grams, and this is a per mole part. Okay, so then after that, we get our molar ratios. So it's going to be moles of this same substance. So in this case, KClO3, just like we did over here, moles of H2O, remember, was moles of H2O. And up above, it's going to be the moles of the other substance, which is the substance for my actual. And in this case, our substance for my actual is O2. So it's going to be moles of O2. Okay, the numbers that go here are going to be our coefficients for each of those. So our coefficient for O2 is 3, and our coefficient for KClO3 is 2. So it's going to be 3 and 2. So 3 for O2 and 2 for KClO3. Okay, so now bring this down, and as we did in the past over here, we are going to do a molar mass step. It'll be 1 mole of this same substance, which is O2, and up above is going to be grams of O2. We get the molar mass of O2. Again, there's 2 oxygens times the mass on the periodic table. So we write down 32 grams of O2. We go ahead and multiply everything across on the top, everything across on the bottom, divide the 2. Okay, so now we see that after our calculation, the theoretical is 117.50 grams of O2. So now remember from the question that our actual was 107 grams of O2. Why? Because it was the one that was attached to the word produced. Anything attached to the word produced, that's going to be our actual. So 107 goes on the top, and the theoretical, which is a 117.50, goes on the bottom. Divide the 2, multiply by 100, and you're going to find out that your percent is 91.06%, okay, for the percent yield. And that is our answer for number 4. And that is what you have to do. So I didn't do number 2, I didn't do number 5. You really have those 2 to do. Make sure you get them done. Any questions, you let me know.